A very common data cleaning step is to have text variables that are in sort of a nasty format or have extra spaces or periods or underscores that you need to remove. And so this lecture is going to be about how do you manipulate those texts programmatically in order to get nice, decent variable names, but also text in the actual data set itself. So again, we're going to go back to this Baltimore fixed camera data because I can't stop thinking about all the speeding tickets that I get. So again, the first thing that we're going to do is download the data set from the web. So we're going to check and see if this data directory exists. And if it doesn't, we're going to create it. Then we're going to download the data from this URL, and we're going to read it into R with read.csv. And so first thing that we can do is look at the names of this camera data. And so this is the column names. And you can see, for example, one of them is this variable cross street, and it has a capitalized S in it. This seems like not a big deal, but every time that you're going to type that into R, you might see you have this extra capital letter and you might miss it, and so R might give you an error. So one thing that you might want to do is make all of the letters lowercase. And so one way to do that with R is to just use to lower. So you can make the names all be only lowercase letters by using the to lower command. There's also a to upper command if you need that in order to make the letters all uppercase. Another thing that you might want to do is separate out variables that have values that are separated by periods. So if we go back to this page, you can see, for example, that this location variable here, it's separated with a dot, and that often happens when you have variable names loaded into R from files. So what we can use is something called the string split command, so it's strsplit. And so then we can pass it the names of our data set, and we can tell it to split on periods. So here I have to use this escape character because a period is a reserved character. And so what I get, if I look at this data set that comes out, split names, which is just a list, you can look at, say, the fifth element, and that's the element corresponding to the intersection variable, and you can see that nothing happened there. It's just one variable because there were no periods in that variable name. But if you look at the sixth element of that list, you see that the location variable has now been split into two components, the location and the one, and the dot has been removed. So we've been able to split that variable out. So one thing that you might want to be able to do then is go through and subset out and just take the part of the variable name that doesn't have the dot in it. I want to give you a very quick aside on lists because the functions that we're going to talk about in a minute depend on that, and we want to make sure that we remember how they work. So here I'm creating a variable, myList, and I'm doing that by passing it letters, numbers, and a matrix. And so if I look at the list, I can see that it has these three different components to it, including some named components. So I can select out the first element of the list, and it returns the letters. I can actually subset by the named variables, or I can actually subset out just the vector by just taking the first element of that list. So one thing that I might want to be able to do is actually remove all the periods and then only get the first part of the variable name. So you can see if I took the sixth element of this list, remember it had two parts to it. It had the location, and then it also had the one that came after the dot. So if I just take the first element of this list element, then I get just the location value. And so what I can do is I can write a function called first element. And first element will just take the first value that comes out of that list. And so I can use sapply to split the name, apply to the split names, which is a list. I can apply the first element function, which will go through, and into each element of that list, it will take the first element out. In this case, it'll take out just the variable names. And when you look at location, you'll see that it has removed the period from that location. So that's one way that you can remove, say, periods from names in data frames. I'm going to go back to this peer review experiment data to show you some other ways that you can manipulate sort of text variables in order to get the answers that you need. So again, I'm going to download the data from the internet, and I'm going to store it into two data frames. One is the reviews data frame, and one is the solutions data frame, where reviews is the set of problems that have been reviewed by peers in this experiment, and solutions is the set of the SAT questions that have been submitted by people. So I can see the data set again looks like this. And so a couple of things that I might want to be able to do is substitute out, say, characters. So in this case, I can see that a couple of the variable names are solution ID and reviewer ID, and they have these underscores in them. And so I might want to remove the underscores from those variables, also from this variable time left over here. And so one thing that I can do is I can use the sub command. I can say every time that you find an underscore, replace it with nothing in the names of reviews. And what you end up with is variable names where all of the underscores have been removed. I can also use gsub to replace multiple instances of a particular character. So for example, suppose I have a variable name that has multiple underscores in it. If I use sub, it will just replace the first underscore. So if I say substitute underscore with nothing in test name, it'll find the first underscore, replace it, but leave the next two underscores alone. If I use gsub, on the other hand, it will replace all of the underscores, so you just get one variable like this. So you can use that to replace underscores and variable names so that you have nice, clean variable names. Or you can also have this happen in the text values that you have in your data set. The next thing I'm going to cover is searching for specific values in variable names or in variables themselves. So here I'm going to go back to the camera data, the fixed camera data, and I'm going to look at the intersection variable. So one thing that I might want to be able to do is find all of the intersections that include the Alameda as one of the roads. So what I'm going to do is I'm going to use the grep function. The grep will take as input a search string that you want to look for, the Alameda, and it will look through this variable and find all of the instances in that vector where the Alameda appears. So it appears in the 4th, 5th, and 36th element of the intersection variable. The other thing that I can use is the grepl command with an L at the end of the grep. And so what that will do is it will look for this version Alameda, it will look for it in this intersection variable, and it will return a vector that's true whenever Alameda appears and false whenever Alameda doesn't appear. And so in this case, you can see that in the 3 of the times, the Alameda appears. And so if I make a table of the true and false values, it's true 3 of the times. So the other thing that you can do is you can sort of subset. So for example, suppose I want to find all the cases where Alameda appears in the intersection, and then I want to say if Alameda doesn't appear, then I want to subset to only that subset of the data. I can do that using this grepl command. So you can use that to subset your data based on certain searches that you want to be able to find. A little bit more about grep. You can also use value equal true as one of the parameters sent to grep. And what that will do is instead of telling you which of the elements that Alameda appears in, it will actually return the values where Alameda appears. So you can see these are the 3 intersections where the Alameda appears in the camera data. The other thing that you can do is you can look for values that don't appear. So say, for example, Jeff Street does not appear in the intersection data. And so it will return integer 0 when that value does not appear. If you look at the length of that, it actually turns out to be 0. So that's a nice way to check. So suppose you want to check and see if a particular value appears in a vector. You can grep for that value and then look the length of the vector. And if it's equal to 0, then you can say that value doesn't appear. A couple of other useful string functions appear both in the stringer package and in the base package. So the nchar will tell you the number of characters that appear in a particular string. So there are 12 characters in my name here. The other thing that you can do is you can take out part of the string. So in this case, I want to take this string and I want to find the 1st through the 7th letters. In that case, that's just my first name. Another thing that you can do is you can paste 2 strings together. So suppose I have these 2 strings and I apply the paste function to them. I get one string that's separated by a space. You can actually set the separation with the sep argument, SEP. A very useful version when you're doing data analysis is often you just want to paste things together with no space in between. And the way that you do that, there's actually a separate function called paste0 that pastes things together without any space in between. In the stringer package, there's a very nice function called string trim. And what it'll do is it'll trim off any excess space that appears at the end of a string. So you get a nice string without excess space at the beginning or the end. So a couple of important points about text and data sets. Whenever possible, you'd like to have all lowercase because missing caps can lead to very difficult to find bugs in data analysis. You'd like them to be descriptive. So in other words, you'd like it to say diagnosis as opposed to DX. You'd like the variable names not to be duplicated and not to have underscores or dots or white spaces, which we showed you how to remove. Variables with character values should usually be made into factor variables, as we've talked about creating factor variables, although this depends a little bit on the application. They should also be descriptive. So for example, if you have a true and false variable, they should be labeled as true and false instead of 0 and 1 or 1 and 0. And male and female should be labeled as such as opposed to M versus F and 0 versus 1. It just makes it easier to see what's going on in the data set.